Welcome back to the Potential Difference Research Lab. Today in this video we're going to be explaining what the nature of infinite efficiency means, and again in a previous video I explained why infinite efficiency is not synonymous with perpetual motion, as lots of people like to claim, such as Dr. Steinitz at the Canadian Journal of Physics. Infinite efficiency means that when the generator is placed on load and when the generator is delivering power to the load, the mechanical power in the drive shaft does not need to be increased. So, according to the current laws of physics, when an electric generator is placed on load and the mechanical input power in the drive shaft must also be increased, otherwise the generator armature reaction, or the negative work performed by the electromagnetic field energy that's created inside the generator around the generator coil's current-bearing wires. When conventional generators produce generator armature reaction, this necessitates a mechanical input power increase to the generator, otherwise the negative work performed by the magnetic field energy inside the generator will stall the system. So in this demonstration, what we're going to be showing is that here we have the input power going to our prime mover, which is an induction motor. And so what we're going to do is bring the system up to steady state speed. Steady state speed is rotational equilibrium, and that means that in the drive shaft at rotational equilibrium, right now this drive shaft is at equilibrium, it's at static equilibrium. That means that the torque in the drive shaft is 0, and the power in the drive shaft is the torque times the speed. And if the torque is 0, then the power in the drive shaft is also 0. At rotational equilibrium, at steady state speed, the drive shaft is neither accelerating nor decelerating. So that means that the torque, the net torque in the drive shaft is 0, and the power in the drive shaft is also 0. So at rotational equilibrium, the prime mover will require X amount of energy, probably around 170 watts or so, in order to establish rotational equilibrium. If this was a hydroelectric generator, for example, a 1 megawatt hydroelectric generator, the mechanical input power required to establish rotational equilibrium for that 1 megawatt generator would be about half a megawatt, so 500,000 watts. So when we take any amount of electricity from our generator and deliver it to a load, that will require that the prime mover will consume additional input power in order to deliver additional mechanical power in the drive shaft to run the generator. Now, again, even if this was a 1 megawatt generator that's idling with a half a megawatt of mechanical input power, even if you take 1 watt or 10 watts from the generator, you have to return 1 or 10 watts back to the drive shaft. Otherwise, even that system will begin to decelerate. So infinite efficiency means that once we have established rotational equilibrium, once we have established the amount of power that the prime mover requires to reach a steady state speed, that's when the mechanical power in the drive shaft is 0. As long as the speed isn't increasing or decreasing, as long as it's a steady state speed, we're at rotational equilibrium. And with this prototype, we have a conventional coil that supplies, conventional generator coil that supplies power to the load, and it operates at less than 100% efficiency, as all conventional generators do. And then on the inside of this E-core, we have a Regenex generator coil that, when it's engaged, it allows the generator to operate at infinite efficiency. So infinite efficiency, again, means that once we establish rotational equilibrium, the power in the drive shaft, the mechanical power in the drive shaft is 0 watts. And when we engage the conventional coil, the prime mover input power requirement will go up. And if the prime mover input power requirement doesn't go up, that's infinite efficiency generator operation. If it doesn't go up above what is required in order to establish rotational equilibrium. So, and also, if this number doesn't go up, but if it actually goes down, which is what you're going to see in the demonstration, if this number goes down to a level that's below the number that's required to establish rotational equilibrium, then that's also infinite efficiency operation. So here we'll be looking at the voltage and the power, the voltage and the current that's delivered to the load by the conventional generator coil, and on the oscilloscope we will be able to see the load current sine waves for the conventional coil and the Regenex coil. So we're going to bring our system up to speed. Okay, so our system is currently operating at steady state speed. The generator is rotating at 3,498 RPM. The prime mover requires 156 watts in order to establish rotational equilibrium, where the net power in the drive shaft, the net mechanical power in the drive shaft is 0 watts. And when we place the conventional generator on load, we will deliver about 8.9 watts to the load, and this number will increase by more than 8.9 watts. And the generator will be operating at less than 100% efficiency. So we went from We went from 155 watts in order to establish 0 mechanical watts in our drive shaft to our generator at rotational equilibrium. And now that we're on load, and we're delivering about 8.9 watts of electricity to our load, the prime mover input has increased by about 20 watts. This is conventional generator operation. And the system is operating at less than 100% efficiency. And as we established yesterday, the black box efficiency of this system as it currently sits is about 40%. And if you want to know what the actual efficiency of the generator is, then you would have to multiply the 20-watt increase by the efficiency of the prime mover as it's at the efficiency of the prime mover at this current speed. So clearly our mechanical power to our generator has increased, and our starting point, our rotational equilibrium starting point, was about 155 watts. And now we're going to demonstrate infinite efficiency generator operation. So pay attention to this number and also the speed of operation. So we required 155 electrical watts to establish 0 mechanical watts in our drive shaft at rotational equilibrium. And when the RegenX generator is on load and it is supplying power to the load, it requires, the prime mover requires less electrical input power and is delivering less mechanical power to the drive shaft, to the generator, when it's on load than when it is on no load at idle. So let's take it back to the steady state idle condition again. So you can imagine that this is our hydroelectric generator, our coal-fired generator, or any generator on the planet, our wind turbine that is rotating at a steady state speed on no load. When the generator is connected to the grid. Additional power must be supplied to the prime mover in order to allow the system to maintain operation. Otherwise, the generator will stall the prime mover. The electromagnetic field energy that's being created around the generator coils in the conventional coil is performing negative work. And now I'll put the RegenX generator coil on load again. Again, now our prime mover is consuming less power than it was at no load, at idle, at steady state speed, and the generator is delivering more power to the load at infinite efficiency than the conventional generator is able to do at less than 100% efficiency. So once again, no load, idle, rotational equilibrium, zero mechanical watts of power in the drive shaft. Prime mover consumes additional electrical input power in order to supply additional mechanical power to the drive shaft, while the generator is delivering electric output to the load. If this was a coal-fired power plant, they'd be burning more coal in order to generate the electrical output from the coal-fired power plant. And if the coal-fired power plant was using RegenX generators, that coal-fired power plant, the generators would be operating at infinite efficiency, and that coal-fired power plant would be consuming less coal while on load, delivering electric power to the grid, than what it was consuming at idle on no load. So that's the difference between infinite efficiency of operation. Again, you can see that the input is basically 135 watts, electrical watts, more than the output of the generator. And if you have any common sense at all, you can realize that this is not a perpetual motion machine. It's a generator that's operating at infinite efficiency, and that's basically it. So thanks again, and the next video that we'll be demonstrating is the bitoroid transformer versus the conventional transformer. The conventional transformer will be operating at less than 100% efficiency, and the bitoroid transformer will be operating at infinite efficiency again. Stay tuned. Thanks for viewing. Bye for now.